This is the first lecture on theory of computation. So here we will learn about alphabets, strings and languages. So alphabets are a set of symbols. Okay, it's a finite set of symbols, and these symbols can be numbers, letters, or any character. Okay, so special characters also. So it's denoted by the set of symbols, or alphabet is denoted by a sigma, where for example we have to, for decimal number system, we have the alphabet as the set of numbers 0 1 2 3 4 till 9. So if you want to write any decimal number 35 463 or whatever, okay, so you have to use alphabets from this. Okay, so even for binary numbers, so binary numbers, how do we represent? So we have the alphabets as 0 and 1. So the sigma or the alphabet is 0 and 1 for binary numbers. For hexadecimal, so we can use represent our numbers using 0 1 2 till 9, then A B C D E F. And for your English, we have small a, lowercase a b c till z, then uppercase a b c till z. Then you also use something like dot, okay, full stop, exclamation mark, all these. So these are all set of symbols, okay, which is called alphabet of the some particular language. So we will now see, so we have the alphabets. For example, in English we learn about alphabets, then we come to form some words from it, okay, which are called string. So string is finite sequences of the symbol. Okay, so for example we learn, okay, A B C D E. Okay, so we learn the alphabets of English, then we try to form some words, okay, like cat, cat, boy, apple. Okay, so we learn all these. Okay, so similarly in automata theory, so we have strings which are formed over the alphabet. So these are finite sequences of symbols. So let's for example say our alphabet is A comma B, then what are the strings that we can make? And strings are just finite sequences of symbols. So I can make A B, there's length 1 sequences, then A B, B A and B B, they are length 2 sequences, and then A B A B A, these are some length 3 sequences, and so on. So you can make an infinite number of words using even a small number of symbols in the alphabet. Like here we have just 2. So W is used to denote a string, and mod of W is the length of the string. For example, if W is A, then mod of W is 5, the length of the string. Epsilon is used to denote an empty string. So after studying string, now let's try to see a few things. Okay, so sigma, let's say in our example is 0 comma 1. Sigma 1 denotes set of all strings of length 1 taken over the alphabet. Okay, sigma 2, so here for length 1, what are they? 0 is one such string and 1 is another such. Length 0 is epsilon, because epsilon is a string of length 0. Sigma 2 is set of all strings of length 2. So here we can have 0 0 0 1 1 0 and 1 1. Set of length 3 you can similarly form. So you might know 0 0 0 0 0 1 0 1 0, and then 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, so these you can form sigma 3, and sigma n is the set of all strings taken from alphabet of length n. So I can ask you a simple question, that how many, what will be the size of the sigma n, okay, for this example, let's say, then it will be like we have n places, so 1 2 3 till n, and I have to fill it with 0 1 or 0 or 1 0 or 1 0 or 1. So there are 2 into 2 into 2 into 2 till n places, so it is 2 to the power of n. And let's say if our alphabet was 0, 1, 2, 3, 4 such places options were there in the alphabet. Then I could have 0, 1, 2, 3, 0, 1, 2, 3. So it would have become 4 to the power of n. And if there was the size of sigma was, let's say, b, not b, let's say x, because we have already used b, so not get confused. So it will be x options are there, so it will be x to the power of n. Now sigma star, also known as lean closure, is set of all strings that can be formed using the alphabet. So it's epsilon union sigma 1 union sigma 2 union sigma 3 union till infinite length. Okay, and sigma plus, you just leave the empty string. Okay, so we will see with some examples which we already have explained here. So sigma is, let's say, 0, 1. So sigma 0 is epsilon. Sigma 1, you have 0 and 1. So we already talked about this. Sigma 3 is length 3 strings. And so, and if you have 0, let's say I have an alphabet which is just 0, then what is sigma star? So sigma star will be, I have empty string, then in string of length 1 sigma 1, sigma 2 is 0 0, sigma 3 is 0 0 0, sigma 4 is 0 0 0 0, and so on. Okay, this is infinite length. And then let's say we have now talk about concatenation of strings. Okay, so we have two words, okay, two strings w1 and w2. So concatenation means that we just append the string, the second string, to the first string. So it is w1 concatenated with w2, it becomes abcxyz. So this is one definition. Then another is reverse of a string. So you simply take, if W is A, B, C, D, then the reverse will become last one, the first, second, last one, the second one, and so on. So D, C, B, A. Now let's consider the language. Okay, so English, we had learned alphabet, then we learned about words or strings, then we come to the language. Okay, so now we want to write a few things. So it is in mathematical, in automata theory, it's a theory of computation, it's set of strings chosen from the sigma star. Okay, so language is a subset, okay, from sigma star. And it is like, we will see with some concrete examples which will make it clear. Let's say sigma is 0 1. Okay, so we have alphabet 0 1, it's simpler to take. So some examples of languages are L1 might be like a set of all strings starting with 1. Okay, set of all strings that start with 1. So first one can be 1, then we can have 1 0, 1 1. So this is sigma 1, sigma 2. Let's write sigma 3. So what will it be? 1 0 0 1 0 1 1 1 0 and 1 1 1. So this is sigma 3. Similarly, you can write sigma 4 also. Okay, sigma 4, what will it become? 1, then you write 0 0 0 1 0 0 1, and so on. Okay, so this tells that, okay, this is the language. So our alphabet was 0 1. Now we are having the language which is the set of all strings starting with 1. So this is the infinite set, as you can understand. Okay, I can have an infinite number of elements here because our length can go till infinity. Then let's say another language is over alphabet 0 1 is set of all strings of length 2. Now what length 2 set of all strings, so it will be 0 0 0 1 1 0 1 1, and this is a finite language. Okay, so here you have finite number of elements. So this was infinite and this one becomes finite. Then we have set of all language, third language can be set of all strings that starts with 0 and ends with 1. So for example, so what can I write here? So you can write, it will be, so it starts with a 0, ends with a 1. Smallest such will be 0 1. Then I can have something in between here, so 0 1 0 1 1. I have 0 1 in between. I have two things, 0 0, then 0 0 1 1, 0 1 0 1, and 0 1 1 1. Okay, so this you can continue. This is also infinite number of elements in this language. L4, set of all strings with equal number of zeros and ones. Okay, equal number of zeros and ones. So here we have, so epsilon also has equal number of 0 and 1. Both have 0 numbers. And 0 1 is another equal number of 1 0 and 1 1. 0 1 0 1, 1 0 1 0, 1 1 0 0, 0 0 1 1, and so on. Okay, this is also, as you can understand, it's infinite number of elements. Okay, in this, another can be, let's say that it can, okay, so I have written 1 to the power of n, 0 to the power of n is greater than equal to 1. So L5 is a language, okay, where you have, first we have ones, n ones followed by n zeros, or 0 to the power of n, 1 to the power of n. This means basically that, okay, n, if n is equal to 1, so it is 1 0, n is equal to 2, it is 1 1 0 0, n is equal to 3, 1 1 1 0 0 0. So this set is also infinite. So now you can understand that this is about the languages, and we will see afterwards that there are languages that are regular and other languages that are not regular, okay, which we will see in the next. But till now, to revise, so we learned about the alphabets, okay, which are set of finite set of symbols. Then we learned about string, finite, which are the finite sequence of symbols. And then we learned about like some sigma 1, sigma 2, sigma n, sigma star, sigma plus. And then what we learned, concatenation, reverse of string, and then finally about languages. So languages describe some property of the strings. Okay, so the set of strings, what property do they have? So for example, it starts with 1, ends with 0, it starts with 1, so all these properties. Okay, so we learned about language. So I hope you enjoyed it. Thanks a lot.